Hi everyone. So this lesson is on proofs involving parallel lines and angles. So the first thing that I'm going to talk about is these theorems and the one postulate here. And this is what we learned last class, which is that when lines are parallel and they form these types of angles, corresponding alternate interior, alternate exterior, consecutive interior, these are the things that are true about them. So remember, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. And remember that this is only if the lines are parallel. If the lines that make the angles are not parallel, then these are not true. So we're going to use these theorems and then the one postulate, corresponding angles, to prove some things about angles. That's what the first part is. So if you take a look at this picture, we're given that L is parallel to M and also A is parallel to B. We show that with the same number of arrows on the lines. And we're being asked to prove that angle 1 is congruent to angle 12. And so what we're going to do, some of you may be thinking, well, aren't those alternate exterior angles? They're actually not, because they're not on the same transversal, like 1 and 13 would be, or 12 and 5 would be, but 1 and 12 are not. They have to be on the same transversal in order to be considered alternate exterior, or really any of these. And so what we're going to do is we're going to find an angle, and there are a few of them, that 1 and 12 both have a relationship with. And so what I mean by that is like, say 5. 1 and 5 are corresponding. 5 and 12 are alternate exterior. Another one could be like 15. 1 and 15 are corresponding. 15 and 12 are alternate exterior. So basically find one of them. So 5 is another one. 13 is another one. I'm sure there are more. But find an angle that they both have a relationship with. And so what we're going to do is we're going to say that 1 is congruent to 15. We're going to say 12 is congruent to 15. And then by transitive, we'll be able to say 1 is congruent to 12 because they were both congruent to 15. So that's how this proof is going to go. So we want to set up your two columns. Restate the given, of course. Okay, so like I said, 1 and 15, and it doesn't matter the order that you do it in. Oops. And put an angle symbol. So angle 1 is congruent to angle 15. And since those are corresponding, that would be the corresponding angles postulate. Okay. Next, we can say 15 and 12. And those are alternate exterior. So that's the alternate exterior angles theorem. You can abbreviate that a little bit. And then now we can do our proof statement, because notice how 1 and 12 are both equal to 15. So now 1 is congruent to, why do I keep forgetting my angle symbol? 1 is congruent to 12. And that is by the transitive property of equality. Anytime two angles are equal to the same one, then they're equal to each other. So there's our first one. Given the lines are parallel, prove two angles are congruent. I would say this is the most common type of parallel line proof that you'll see. The next one is kind of similar, but it deals with being supplementary, like adding to 180 instead. And so we're given that L is parallel to M again. And I'll restate that given information. So let's see what we're trying to prove here. We're trying to prove that 1 and 6 add to 180. And so 1 and 6 don't have a relation, like their relationship doesn't have a name if you look at the picture. So what you want to do again is you want to find an angle or identify an angle that they both have a relationship to, and then use that to try to help you do some substitution to get it to say that 1 and 6 add to 180. So what pops out to me is angle 3 here. I notice that 3 and 6 are supplementary because they're consecutive interior angles. And then also 1 and 3 are congruent because they're vertical. And so what we can do is we can start off by saying that 3 and 6 are supplementary by the consecutive interior angle theorem. Then we can say they add to 180. Then we can say 1 and 3 are congruent, and then do some substitutions. So you kind of have to like make a plan when you're doing this, like find an angle they're both related to, and then figure out how you can connect them. So I'm going to say next that angle 3 and angle 6 are supplementary. And that's by the consecutive interior angles theorem. Since they're supplementary, think about, we know that means they add to 180, right? So we can say the measure of angle 3 plus measure of angle 6 equals 180. And that's definition of supplementary. Notice that this statement in step 3 is actually very similar to what we're trying to prove, right? So we're trying to prove that 1 and 6 add to 180. We have 3 plus 6 equals 180. And we know that 1 and 3 are equal, right? Because they're vertical. So that's how you get to what you're trying to show. So next I'm going to say that angle 1 is congruent to angle 3, and that's vertical angles theorem. And then remember, if I'm going to do some substituting here, I do have to change the form. Right now it's in the angle like congruent form. We need to switch it to the measure form, because if I'm going to substitute measure of angle 3 with measure of angle 1, right now I don't have it listed as measure of angle 1. So I have to switch it. And so this is what that looks like. So I'm going to have measure of angle 1 equals measure of angle 3. How do I know that? Well, because in the previous step, I said they were congruent angles, and I know the definition of congruent angles. Now that I have it in the measure form, I can substitute it anywhere I want in for angle 3. So right here is the ideal spot, because then that'll take us to what we're trying to prove, which is that the measure of angle 1 plus the measure of angle 6 equals 180. And that would be substitution. Sorry, my work is so messy. This stylus is not the easiest to write with. So anyway, okay. So these first two examples are when we're given lines are parallel and we're asked to prove something about the angles. We just use the regular theorems. On the second page, we're going to use something called converse. And so this page, we are using proofs. We're doing proofs involving converses. So first, what is a converse? A converse is when you take a statement, it's called a conditional statement. All these theorems and postulates, those are conditional statements. It basically is an if-then statement, kind of like the statement, if it is Monday, it is an asynchronous day. That's a conditional statement. The converse is if you flip the if and the then. So if I wanted to do the converse of my example that I just made up, it would be, if it is an asynchronous day, it is Monday. So see how I flipped it? First I said if Monday, then asynchronous. Now I'm saying if asynchronous, then Monday. So pretty much any theorem that you can think of can have a converse for the most part. And so the converse of these parallel lines theorems are used to prove lines parallel. So anytime you are asked to prove that lines are parallel, you're using a converse. So each theorem that we talked about on the front page has a converse. So first is the converse of the corresponding angles postulate. It says, if I have a pair of corresponding angles that I have that are congruent, then I could conclude that the lines that form those angles are parallel and prove that those lines are parallel. Same thing with all the others. I have the converse of the the alternate interior angles theorem. If I have a pair of, oh man, I really messed this up. If alternate interior angles are congruent, then the lines that form them are parallel. So then same thing with alternate exterior and same thing with consecutive interior. So any theorem can have a converse. And again, these are used to prove that lines are parallel. So if you take a look at these examples, see what I mean? Prove lines parallel. It's asking us to prove that A is parallel to B versus the front that had us prove things about the angles. So I know just looking at a proof that it's going to be one where I have to use a converse. And I know that because of what we're being asked to prove. So you kind of do it in sort of a similar way. There's just one thing that's tricky. Let me move this up a little bit. there's just one thing that's a little bit tricky. So in the given, we're given that L is parallel to M, and we're given that 1 is congruent to 10. We are not given that A and B are parallel. That is what we're trying to prove. And so how this makes it tricky is we can't use any relationships going this way or this way on these transversals. Like we can't use corresponding angles postulate or stuff like that because those lines aren't parallel yet. And so what our goal is going to be is, again, like the first one, we're going to find an angle that 1 and 10 both have a relationship with. And then from there, we will, use some, like name some congruent angles, and then we'll end up using some transitive again, and then use a converse. So the one that's popping out to me, I don't know about you guys, is angle 5. I see that 1 and 5 are corresponding, 10 and 5 are corresponding. And so the only ones that I could say are congruent right now are 10 and 5 because they're made with these parallel lines. See how there's L and M are parallel on this transversal. So I can use the relationships going this way. I just can't use them the other way. And so what we're going to do, I never restated the given. And so what we're going to do is I can say that 5 and 10 are congruent. If 5 and 10 are congruent and we were given 1 and 10 are congruent, wouldn't that make 5 and 1 congruent by transitive property? Can't talk today. So by transitive property, 1 and 5 would be congruent as well. And so once I show 1 and 5 are congruent, those are corresponding angles. Then I can use the converse of that postulate to say that the lines that make them are parallel. So if all of that was kind of confusing, just watch, you'll see. So I'm going to say angle 5 is congruent to angle 10. And that's because of the corresponding angles postulate. Next, because 1 and 5 are both congruent to 10, I'm going to say that 1 and 5 are congruent. And even though 1 and 5 are corresponding angles, that's not why they're congruent right now, because those lines aren't parallel yet, A and B. They're congruent because I used transitive. And then now, since these corresponding angles are congruent, I can conclude that A is parallel to B. And that would be the converse of the corresponding angles postulate. Because this 1 and 5 right here, those are corresponding. So whichever angles you're using to show that the lines are parallel, you use the converse of whatever kind of angles they are. So there's our first example. The second example has to do with supplementary angles. I wanted to do like one of each kind. So the last one, let's set it up. This one can be done in a few different ways. Same thing with actually most proofs. They can usually be done in multiple ways. Oh dear. So I'm going to do this one using congruent supplements theorem. You guys probably don't remember that theorem, but we did learn it, and we used it a couple times on a practice, but never like on a quiz or something. And basically what congruent supplements theorem is if you have two angles that are supplementary to the same angle, that makes them congruent to each other. So it's sort of like transitive, but for supplementary angles. So again, two angles supplementary to the same one are congruent. So if you look at the picture, they told us that 5 and 14 are supplementary. We are trying to prove L and M are parallel, but we do know A and B are parallel. So this time, knowing A and B are parallel, we can use the relationships this way on these transversals, but not this way on those transversals. So it's a little tricky. You really have to pay attention to which angles you're given are parallel. And so just like the last one, we're going to find an angle that 5 and 14 both have a relationship to. So I'm looking for one that 5 and 14, one of them is supplementary to and one of them is congruent to. There are a few different options. You want to make sure that the first thing you say is using A and B as the parallel lines. So like if I look at angle 2 here, do we see how angle 2 and angle 5 are formed by A and B? And those are parallel. So that means the relationships are true with 2 and 5. 2 and 5 are consecutive interior angles, which would make them supplementary. And I can say that right now because, again, A and B I know are parallel. So I could say that angle 5 and angle 2 are supplementary. working. That always happens at the end of a video. It's very frustrating. Anyway, so like I was going over before, we were talking about how we know that 5 and 14 are supplementary, and then I identified 2 as one that they both had a relationship with. Remember, these lines were parallel. This was A and B. And then this is L and N. Or M. I forget which one it was. Whichever. It doesn't matter. M. We'll go with M. Okay, so I was just about to write that 5 and 2 are supplementary because they're consecutive interior. So once we say that 5 and 2 are supplementary, then we can use congruent supplements theorem. So 5 and 2 are supplementary because of the consecutive interior angles theorem. And so now that 5 and 2 are supplementary, see how 14 and 2 are both supplementary to 5? So now they can be equal to each other. And again, that's called congruent supplements theorem because 2 angles are supplementary to the same one. Now that 2 and 14 are congruent, think about how those are corresponding angles. So I just showed that this pair of corresponding angles are congruent. And so therefore the lines that make them, L and M, are parallel. And that would be because of the converse of the corresponding angles postulate. I didn't intend to have 2 examples where it's the same converse. If these 2 angles were like alternate interior, let's say, it would be the converse of the alternate interior angle theorem. Whatever angles you show are congruent, whatever type they are, that's which converse you use. So hopefully these are helpful for you to do the proofs packet. Please let me know if you have any questions.